Hi, my name is Michael Richmond. I'm from a small city in the state of Wisconsin, USA, called Schofield. And this is my week 1 assignment, sound and signal flow. Audio propagation. What is it? Well, it's the way that sound moves through a particular medium, solid, liquid, or gas. In our case, we're mostly going to be concerned with how sound moves through the air, which is a gas. Why is it important in music production? Well, the conditions by which sound moves change what a listener hears, and so special attention needs to be given to how the environment itself and the placement of our recording devices and musical instruments changes the sound. Audio amplitude. What is it? Well, it's an objectively measurable level of the size of a sound wave. Sound propagates in the form of a wave. Our ears perceive this as a certain volume. Scientists measure that volume in decibels. Decibels in a DAW or digital audio workstation are expressed as dBFS, full scale. 0 is the max volume the computer can deal with, and a negative number moves as an indication of a smaller amplitude. dBSPL, sound pressure level, is a number from 0, the minimum of human hearing, on up as the amplitude or loudness increases. Why is this important in music production? Well, we cannot use the term loudness without expressing it as something objective like decibels. And just as we know that our DAW and inputs require a certain decibel level, audio equipment like microphones have a dynamic range, which is a range of decibels that they can work with. And we need to know what they are so we can adjust accordingly. Audible frequency. What is it? Well, it's a vibration that repeats within a certain time period. The faster the vibration, the higher the frequency, and vice versa. Scientists measure frequency in hertz. The higher the value in hertz, the higher the value in frequency. A musical note has a certain frequency attached to it. For example, a middle C or C4 has a frequency of 264.63 hertz. The average human female voice tops out at around 1046.5 hertz. The highest note on an 88-key keyboard, 4186 hertz. Why this is important in music production is because we have frequency response in our microphones, which is a certain range of frequencies that it can pick up and it can't. And it's important that we choose the correct microphone for the frequency of the item we're recording. And also we work with equalizers, and those can take out or put in certain frequencies as necessary. And we're also going to learn about many other tools in this course, presumably, where we'll be able to manipulate frequency. So it's important to have a good understanding of this concept. Timbre. What is it? Well, it's the unique output personality of everything that creates more than one static frequency. Why it's important in music production? Well, we learned in class that pretty much only the sine wave emits one single frequency. Everything else that can create sound has minor fluctuations in frequency, and it makes things from a human voice to a violin to a piccolo to a tuba sound different. And we have to take those things and try to make them sound the way we want them to. Music can be good or bad subjectively. One person likes one thing, another person likes another. But we need to be careful that when we pair, say, two instruments together, one instrument doesn't cancel another out or overpower another piece in our performance. So that's why timbre is very important. That concludes my presentation, and I hope this was a helpful boiling down of the concepts we talked about this week. This is my very first PowerPoint presentation via YouTube, so try to go easy on me, but give me a few pointers, if you would, down below, and I look forward to your critiques, and I will be talking to you next week.